Hello students, this is Mr. Holly. We're going to be looking at the problem set from lesson 2. First we're going to do set 1, and I'm kind of going to go through this at a brisk pace because you had several to answer, but they shouldn't have taken very long. So let's look at B. In B we have 3x plus negative 2, or excuse me, plus the sum of negative 2 and 4x. So this is all addition. So I'm going to remove these parentheses because I know that addition is commutative and associative. I can add it in any order and in any group. So I'm going to remove those parentheses. And now I just want to combine my like terms of 3x and 4x. That would be 7x plus negative 2. I can come down here and I can confirm that these are equivalent because that's our goal. We're showing that this expression and this expression have the exact same value. And the way we show that they're the same value is by substituting in a value for x to prove it. 3x plus negative 2 plus 4x. And I'm going to substitute 5 in. 3 times 5 plus negative 2 plus 4 times 5. 15 plus negative 2. Plus 20, that's 35 plus negative 2, and that is 33. Over here I'm going to use the expression that we got once we simplified, the expression in, we would call that standard form. 7x plus negative 2, that would be 7 times 5 plus negative 2, that's 35 plus negative 2, which is 33. So we see we get the same value when we substitute in x for 5. And what that does is prove that this expression that we began with and the expression as we wrote it in standard form are the same. I'm going to speed up and we're going to go through this much faster. All right, negative 3x plus 2 plus 4x. Here are my like terms. I'm going to do x plus 2. When you verify, you should get 7 for each expression. Plug in 5 plus 2, I get 7. Plug in 5 up here, I would get negative 15 plus 2 plus 20. Negative 15 plus 22 is 7. So I'm going to get 7 on both expressions. D, 3x plus negative 2 minus 4x. So I'm actually going to rewrite all that as addition. Minus 4x is going to be plus negative 4x. Now that it's all addition, I can drop those parentheses that were there. I can drop those. And I'm going to find common terms here, like terms, 3x and negative 4x, and that's going to give me negative x plus negative 2. All right, when you plug in 5 to verify, you should get negative 7. All right, 3x minus 2 plus 4x, that's going to be 3x plus the opposite of 2 plus 4x. All right, so everything in here becomes the opposite. So that's going to be a negative 2 and a negative 4x. So that's negative x plus negative 2. Again, you should get negative 7 when you verify. 3x minus negative 2 plus 4x. So this, again, we are adding the opposite of everything in this box, or in these parentheses, excuse me. So that's 3x plus the opposite of negative 2 is 2. And the opposite of 4x is negative 4x. So that's going to be negative x plus 2. When I substitute in 5 for x, I should get negative 3. All right, 3x minus the difference of negative 2 and 4x. So I am subtracting, so that means I'm going to add the opposite of negative 2, which is 2, and I'm going to add the opposite of negative 4x, which is 4x, and I get 7x plus 2. 3x minus 2 minus 4x, so I'm going to subtract or add the opposite of 2, which is negative 2. and I'm going to add the opposite of negative 4x, which is positive 4x. This is key when I'm subtracting a binomial, or I'm subtracting an expression that has two terms like this, it's in parentheses. If I have subtraction in that, I need to think about this second term as a negative term, like I'm adding a negative here, so that when I subtract this term, it actually turns into addition. Does everybody notice that becomes addition? Okay. All right. Negative 3x minus negative 2 minus 4x. So again, we're adding the opposite of each of these terms. This is plus negative 4x. So this becomes plus the opposite of negative 2, which is 2, and plus the opposite of negative 4x, which is 4x. So like terms are negative 3 and 4, or negative 3x and 4x. I get x plus 2. I haven't been talking about the verifying. When you verify down here, you're going to get 37. When you verify here, you're going to get 33. When you verify here, you should get 7. Remember, you're plugging into both expressions. I'll do one more verify for you on the next set. Okay. Problem A. We would like to write these in standard form. 4y minus 3 plus y. So that's going to be plus negative 3 plus negative y, because we're adding the opposite of each of the terms. So this is a negative y, and this is positive 4y. That's going to create 3y plus negative 3. Let's go ahead and we'll verify it together just to make sure. 4y minus 3 plus y and 3y plus negative 3. So here I get 4 times 2 minus 3 plus 2. That's 8 minus 5, which is 3. How about over here? 3 times 2 plus negative 3. That's 6 plus negative 3, which is 3. These are equivalent, which means both expressions, the one we started with and the expression that we wrote in standard form, are equivalent, because when we plug in the same value for y, they evaluate to the same value. Things that have the same value are equivalent. 2b plus 1 minus b. So it's 2b plus 1, and I'm going to change this subtraction to addition, plus the opposite of b, or plus negative b. And now that it's all addition, these parentheses become obsolete or unnecessary. B plus negative b is b, and that's plus 1. Here are like terms. Okay. And when I evaluate, I should get negative 3. Over here I have 6c minus 4, so I'm going to write 6c plus negative 4. Now, I'm subtracting c minus 3, which means I want to add the opposite of each of these terms. So that's going to be plus negative c, the opposite of c, plus, this is minus 3, so I have to think about it as a negative 3, minus negative 3, so that becomes plus 3. Now, this is the first problem where I've had variable terms and constant terms, and I'm combining both of them. 6c and negative c is 5c. Negative 4 and 3 is negative 1. 5c plus negative 1. When I substitute in, I should get negative 36 when I verify. Okay. Continuing. D plus 3d. Well, I'm actually just going to go ahead and write that as 4d, because I can simplify that immediately. Minus the opposite of d plus 2. So minus negative d, when I change that, I would be doing plus the opposite of negative d, which is d. Minus 2 is going to be plus the opposite of 2, which is plus negative 2. That's 5d plus negative 2. right? If I substitute in to verify, I should be getting 13. All right, let's go over here to E. Negative 5x minus 4, so negative 5x plus negative 4, minus negative 2 minus 5x, that's going to be plus 2, minus the opposite 2, minus negative 5x, that's going to be plus 5x. So now I have a negative 5x and a positive 5x. Oh, there's a great vocabulary term for that. What will we call those? Opposites. Additive inverses. They're going to create 0. There is going to be no variable term. And here are my constant terms, negative 4 and 2, so I'm going to get negative 2. Now, verifying would be kind of interesting on this one because I've already said my expression is negative 2. What happens if I plug in? Well, let's plug into this expression up here. Negative 5, I'm putting in negative 2 for x, minus 4 minus negative 2 minus 5 times negative 2. Okay, it's a lot of numbers there. Negative 5 times negative 2 is 10 minus 4 minus, over here I have negative 2 minus 5 times negative 2. So that's going to be negative 2 minus negative 10, or so I can say plus 10. So this is 6 minus negative 2 plus 10 is 8. 6 minus 8 is negative 2. And the trick here is because these variable terms eliminate, no matter what value you plug in, you should actually get negative 2 as your as you evaluate. That should be the value that you get. No matter what value we would plug in, we would get negative 2 every time. Because our variable terms cancel, and this simplifies down to just a constant. Okay, 11f minus negative 2f, so that's going to be plus 2f minus positive 2, so that's going to be plus negative 2. And that's going to be 13f plus negative 2. And if I plug in 1/2, that would be 13, I got to think about that for a second, 13 halves plus negative 2, which would be 6.5 minus 2, so 4.5, 4.5, 4.5, either way. So either expression you plug this into, you should get 4.5. All right, continuing on, negative 5g plus 6g plus negative 4. Because we're adding here, I can just make that plus negative 4 and remove the parentheses. Negative 5g and 6g combine to make g plus negative 4, and that is my simplified expression. When I verify, I should get negative 6, and if I plug it in up here, I should also get negative 6. 8h plus negative 1, minus is plus negative, minus h plus 3, so that's going to become plus negative h plus negative 3, and that's going to be, combine my variable terms with the h, 8h and negative h is 7h, and negative 1 and negative 3 is going to be negative 4. When I verify, I should get negative 25. 7 plus w minus, or plus negative w plus negative 7. Now guys, if you looked at this problem, you should see that 7 plus w and w plus 7 are the same thing. What happens when you subtract the same value from the original value? Well, you end up with nothing. 7 and negative 7 is going to create 0. W and negative w going to create 0, and it's 0. And you can plug a value in there to confirm. Plug in negative 4, and this becomes 3. This becomes 3. 3 minus 3, 0. It's just going to be 0 when we verify. Or excuse me, it's going to be 3 whenever we, excuse me, it will be 0 when we simplify. Anytime we try to write it in standard form, those values just cancel out. They eliminate. Okay, 2g plus 9, 8